Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 1. Three capacitors C1, C2 and C3 are connected in a combination as shown in the figure. We need to identify the correct statements. So this is the electrical circuit that is given to us, and we are having three capacitors C1, C2 and C3 connected to a battery of 10 volts. So first try to find out the charge required by each of the capacitors. So for that we need to convert this into a single capacitor. So we can see that C2 and C3, they are in parallel, so they can be added simply, because when the capacitors are in parallel, so C equivalent will be C2 plus C3 for the parallel network. So I can redraw the circuit. This is C1, that is 4 microfarad, and C2 plus C3, that will be 12 microfarad, and then this whole combination is connected across the 10 volt battery. Now again, these two capacitors, that is C equivalent and C1, they are in series. So when the capacitors are in series, we need to add them in this manner: 1 upon C equivalent dash, that is equal to 1 upon C1 plus 1 upon C equivalent. So that will be equal to 1 upon 4 plus 1 upon 12, and when we solve it out, 12 is LCM, 3 plus 1 in the numerator, and it is equal to 1 by 3. So finally we can write C equivalent dash is equal to 3 microfarad on taking reciprocal of this, because it was 1 upon C equivalent dash. Now we can redraw the circuit with a single capacitor of 3 microfarad, and this 3 microfarad, it is connected across the 10 volt battery. Now we need to find out the charge that is drawn from the battery. So let me call it as Q1, and we know that Q is equal to CV. This is the formula. So in order to find out this Q1, I can write Q1 is equal to C equivalent dash into V. That will be equal to 3 multiplied by 10 to the power minus 6, that is 3 microfarad, multiplied by 10, because it is connected across 10 volt battery. On solving it out, we will be having 30 microcoulomb. That is the charge drawn from the battery Q1. So it means this battery, it is giving a charge of 30 microcoulomb, and this charge, it is going like this, and first it is charging C1. So the charge acquired by C1, it is 30 microcoulomb. Now this Q1, it is getting divided into two parts, Q2 and Q3 in the parallel network. And for that, first we need to find out the potential difference across C2 and C3. So that we can obtain by first finding the potential difference across C1. So let me redraw the circuit and find the potential difference across C1, C2 and. So this is the circuit that we are having. Now the charge that is drawn from the battery, it was 30 microcoulomb, and the charge across C1, it was again 30 microcoulomb. Now V1 is the voltage across C1. That can be obtained as Q is equal to CV is the formula. So V will be equal to Q by C. So Q was 30 multiplied by 10 to the power minus 6 divided by 4 multiplied by 10 to the power minus 6, because C1, it was 4 microfarad. Now I can solve it out as 7.5 volt. So if out of 10 volt, 7.5 volt is dropped across C1, the remaining 2.5 will be dropped across the parallel combination of 4 microfarad and 8 microfarad. And in parallel, the voltage is same. So across C3, it will be 2.5 volt, and across C2, it will be 2.5 volt only. Now, the charge across C2, that is Q2, and charge across C3 is Q3. So I can find Q2, that is equal to C2 into V2. So voltage across C2 is 2.5 and capacitance is 8 microfarad. So it will be 8 multiplied by 10 to the power minus 6 multiplied by 2.5. That will come out to be 20 microcoulomb. So this is the charge that is across C2. Now charge across C3, that is Q3, that will be equal to C3 into V3. So C3 was 4 microfarad. 4 multiplied by 10 to the power minus 6, multiply it with V3. The voltage across C3 is again 2.5 volts. So it will come out to be 10 microcoulomb. Also, if 20 microcoulomb out of 30 is divided to C2, so the remaining 10 will be in C3, and that's what we are getting with the formula as well. Now let's examine the statements that are given to us. The charge on capacitor C1 is greater than the charge on capacitor C2. So across C1, the charge was 30 microcoulomb and C2 was 20 microcoulomb that we have obtained. So statement 1 is correct. Also, the charge on capacitor C1 is the same as that on C3. But on C3 it is 10 microcoulomb, but here it is saying that it is same. So this statement is wrong. First was correct. The charge on capacitor C1 is 30 microcoulomb. Yes, it is 30 microcoulomb. That is what we have obtained. So we can see that the statement 1 and statement 3, they are the correct statements, and statement 2 is wrong statement. So out of the 4 options given, C is the correct answer because it says both 1 and 3 are correct. And that's the answer for this question. Keep learning, keep practicing, keep excelling.